Hello pre-calculus students, and welcome to a video using the double angle and half angle formulas to actually find some angles now. So this is our first examples. This is the fourth video in a series of 9 videos. The rest are all examples. So let's start right out with using these formulas. So here we go. We're looking at a given situation where the cosecant of theta is negative root 5, and we know that the cosine is less than 0. And we're going to be looking for the cosine of 2 theta. So just as a reminder, the cosine of 2 theta, we can use a couple of different formulas for this one, but I'm just going to choose to use 2 cosine squared of theta minus 1. Now we don't know the cosine of theta, so we need to actually do a little bit of reference angle drawing here. So we're going to look at this given information and try to see if we can draw a nice reference angle with that. So first of all, for the cosecant to be negative negative root 5, we know that the cosecant of theta is less than 0, which means that we also know that the sine, its reciprocal, the sine of theta, is less than 0. So that tells us we're talking about an angle that's either down here or down here with the sine less than 0. We also know that the cosine is less than 0, so that's the x value, so we know it's got to be over here or over here. And that leaves us only one possible quadrant where both of these situations could be met, and that's the third quadrant. So I'm going to draw a third quadrant reference triangle. Now I notice some students, when they draw their reference triangles, they float them without the coordinate plane, as if it takes more than 10 seconds to draw an xy plane first and really put these in the right position. And sometimes that leads to getting confused about the sign, positive or negative sign of things. And so I really recommend taking that time. This is going to be our reference theta. And we know that the cosecant, by definition, is r over y. So we know that the cosecant of theta is r over y, and that equals negative rad 5. We know that the radius is always positive. We can put this over 1, but it really has to be the positive square root of 5 over negative 1, because the y can be negative while the r cannot. So we can now put this information into the reference triangle. So the radius is rad 5, and the y value is negative 1. And we're going to use Pythagorean theorem to find the x value. Once we have a good reference triangle, as long as everything's correct on that, we should have an easier time doing the rest of the work. So let's look at, we're looking for x right now, and we know that x squared plus y squared, which is negative 1, equals rad 5 squared. So x squared plus 1 equals 5, x squared equals 4, x equals plus or minus 2, and we decide by looking again at that reference triangle. We see that it's in the third quadrant where all x values are negative, so we're going to put this is negative 2. All right, so we've got our triangle, and we know pretty much everything that we're going to need about theta, sine, cosine, tangent, and so on. In this case, what we need is the cosine, and we know that the cosine of theta is going to be from here, it's going to be the adjacent, which is negative 2 over rad 5. So this is going to be 2 times negative 2 over rad 5 squared minus 1. I don't need to really bother rationalizing the denominator because I'm going to square this right off the bat. So I have 2 times 4 over 5 minus 1, which is 8 over 5 minus 1. 1 is really 5 over 5. So my answer here is nice and simple, 3 over 5. Okay, the next one won't be quite as simple, but that's basically the idea. Okay, for the sine of alpha over 2, we don't have as much choice of formulas, and we only have plus or minus the square root of 1 minus the cosine of theta. And that's over 2, and the 2 is inside the radical. So we need the cosine of theta, and we have the cosine of theta. And it's right here. Again, it's the same thing we used last time. It's going to be from theta, it's going to be adjacent over hypotenuse. So off to the side here, the cosine of theta is negative 2 over rad 5. Now, before I put that in here, I'm going to rationalize the denominator. It just makes things simpler unless we get that unusual case where we are squaring it. If we're squaring it, we don't need to bother with this, but I'm just going to write this as here, negative 2 rad 5 over 5. That's with a rational denominator. So what we have is we have plus or minus the square root of 1 minus negative, so that's plus 2 rad 5 over 5, and that whole thing is over 2. Okay, let's get a common denominator for this stuff in here. We're just going to work on this for a moment and get a common denominator, which will be 5. Okay, so we're going to have plus or minus the square root of 5 over 5 plus 2 rad 5 over 5, and that's all over 2. And that's plus or minus the square root of 5 plus 2 rad 5 over what is now a common denominator of 5, and that's all over 2 over 1. And you're still inside the radical, you're still looking at two fractions. You can multiply by the reciprocal, so you can make this numerator would be multiplied by 1 over 2, and we would get plus or minus the square root of 5 plus 2 rad 5 over 10. 2 times 5 is 10. Okay, now that's not our final answer because we still have to decide, well, which one are we going to pick, plus or minus? So what we have to keep in mind is that the real theta, and this is theta up here, this is the reference theta, the real theta is somewhere in that quadrant though. So the real theta is a big angle like this, and that angle being in quadrant 3 is somewhere between 180 and 270. So we know that theta is greater than 180 and less than 270. But we want to know the sine of half of theta. We want to know theta over 2. So we just need to figure out which quadrant theta over 2 has to be in. So again, we start with theta because that's what we have our reference triangle based on, is theta. And again, this whole thing is theta. But we need theta over 2, so we just divide all three parts by 2. And we know that theta is greater than 90, less than 135. And so that is in quadrant 2, right? Greater than 90, less than 135 is somewhere over here. And so in that quadrant, again, we're looking at a sine of an angle. We know that that angle, I'm sorry, this is theta over 2 here. We know that that angle theta over 2 is in the second quadrant, and we know that the sine in the second quadrant is positive. Okay, so that's how we choose which sine this is going to be. So our final answer is positive 5 plus 2 rad 5 over 10. Okay, again, we're looking to decide whether this angle is positive or negative. We know that this angle, which is twice as big, this angle here, which is twice as big, is in quadrant 3 where the sine is negative. But we know that half of this angle, half of the angle that we are originally working with, the one that we know about, theta, has got to be in quadrant 2 where the sine is positive. And it has to be in quadrant 2 because of this kind of reasoning right here. Okay, I hope you found this helpful.